Hi guys, so I thought I'd do a really quick video. A friend of mine was in the shop the other day. He's a buddy of mine from the army. It's the first time he's ever been here. I've not seen him for years, and he asked me loads of questions about what we do and how we go about it, and then asks why we do things. So he's from like an engineering background, but doesn't have any use for knives outside of his old military career, and has sort of moved on from all that. So he asked me all these engineering like pertinent questions that made a lot of sense and were had quite interesting answers that I don't think have been covered really, or perhaps we haven't made it clear, or other knife makers don't really go into. The first one is, why do we mirror polish things? Obviously there are a lot of different finishes for knives. Either brush finished, or Scotch-Brite finish, or acid washes, or stone washes. But we are quite well known for our true mirror polishes. There's a few sort of elements to it, but I'm going to just cover the really basic ones. The first one is people like shiny things. People look at a shiny knife and go, wow, that's really sexy. I like that, and they're instantly drawn to it. That isn't the main reason we do it, obviously, but that is one of the reasons. The other one is that many makers, when we first started out, many makers didn't do it. So it wasn't like an industry standard for custom makers. There are several reasons for that as well. The first of which is that it's really hard to master. It's really expensive. It's quite dangerous. So when you're mastering it, you have to be willing to like get hurt a little bit, because it can really hurt you. You're using quite aggressive polishing mops, and if it comes off the mop, it's going to hurt you. It's the most dangerous tool in the workshop. And if you know any people that polish metal for a living, you'll probably see that they've probably broken multiple fingers and all that sort of stuff. So people doing it in their shed on their own, it's not that sort of, it's sort of like avoided a little bit. So people go for these like brush finishes. It takes a massive amount of work, because a lot of it's all hand sanded, and then on the mops as well. And then those pastes, the correct paste and the correct mops, are quite expensive. So yeah, a lot of makers didn't do it when we started out, and that's one of the reasons we wanted to do it, because we wanted to offer it to our customers as something that was a little bit different. Another reason is that mass production knives don't do it at all, really. They sort of do like tumbled stuff, so they chuck it in a vibro tumbler and it comes out and it's got a semi-decent sheen, but they have like drag lines in them, and they've got pitting and marks in them, and they're never a true mirror. So we try and avoid that as well, and we do give a true mirror polish. I've got one here actually, and now this is just going to reflect everything in the camera, but you can see that is a true mirror polish. Even the edge is a true mirror polish. Now that is really hard to achieve on a hardened piece of tool steel. If anyone that does metal work or anything like that, you'll know exactly what I'm talking about. I've got another one here. This is a broader blade. And you never get it perfect all the time. And obviously all steels are different and all steels behave. Some steels don't even polish at all. So yeah, there are, however, several technical reasons. And when we first started making knives specifically for the hunting industry, we really upped our game on making that work and making that polish work. The first major one is that it prevents rust. The rust doesn't have a sort of key, a bond to get to. Now obviously we use a lot of stainless steels, and what we'd always advise is that stainless is two words. It stains less. You can still rust a stainless steel blade if you mistreat it, or you keep it in a damp or like acidic environment. It will still rust or corrode to some degree. Obviously it won't corrode to the same degree, but if that steel has been abraded or scratched or anything like that, that rust will take hold eventually, and it will pit and tarnish and stuff like that. The other reason is it keeps a knife clean. It helps keep it clean. When you wipe that knife off, nothing's being left behind, and any grit or scratches not being left behind in the surface of the steel, which in turn helps prevent creating breeding grounds for bacteria. So if you like wipe the blade, you're going to always keep like blood or whatever, especially if you're a hunter, you're going to put something dirty on that knife eventually. It's going to sit in those little scratches and it will just breed bacteria. So that really helps like keeping that knife clean. And then the oil that we put in our kits obviously if you were then to clean your knife and put that over the top, that again just fills all those little voids and helps stop that bacteria then multiplying. So yeah, there are technical reasons and there are aesthetic reasons, but it is just an interesting little point of our trade and the way we do things. So in true Squaddy style, his next question was pretty on the nose. He says to me, you keep banging on about stabilization and this material is stabilized or stabilized X, and he says, what does that even mean? What do you mean by that? Like, do people know what that means? I'm pretty sure there are lots of people that know what that means, but I figure it might be worth explaining anyway. Stabilization is the process whereby we take a piece of wood or bone or antler or something like that, we put it in a vacuum chamber, we suck all the air out, and that draws in a resin that we've poured in on top. That then gets put in it'll get left for a bit, it gets then put in a pressure chamber, we force more resin in, as much as it will take, gets kept under a certain pressure for several days, and then is thermally cured. There are a few versions that cure naturally, like epoxy versions and resin versions, like 2-pack epoxies. But the two main things you need to take away is that there are open cell and closed cell stabilization. So it does help to some degree, but open cell means exactly that. There is open pores on the surface or in the material, meaning that it can ingress blood or moisture or anything like that, and it will move around, or it won't, it needs to settle a little bit. Usually done with like seasoned materials. Closed cell is what we use. We don't use anything that is open cell, on the basis that it means that anyone ordering materials from us, or knives with these materials on rather, means that they are safe in the knowledge that it's never going to move around, it's never going to take in blood or moisture, and it means that it's food safe as well, and it doesn't breed bacteria. So all the hunting compliance stuff about injection molding and all that, you can get away now with all these new woods that are stabilized. So I've got a few examples here. This one is a stabilized poplar bell. Now this weighs like twice as much as it did originally. So it's taken in all that resin, and it is literally rock hard. They're really, really tough, and they look amazing because it brings up all the grain. There's another one here, which is that's a 3,000-year-old bog oak from the Black Forest. And then these I've got here, that is a 60,000-year-old woolly mammoth tooth block, so it's like 4 or 5 blocks per tooth. This one's prepped, ready for a knife, and this one is a piece of woolly mammoth ivory, and you can see the rads in it there as well. And again, really, really hard, really, really tough. We know when we put those on knives, they'll last as long as we ever want them to, or wherever the customer wants them to, and they're not going to ingress any blood or moisture, so they do comply with all the food handling regs, which is what we do here. We make a lot of knives for hunters, so we just have everything, blanket everything, complies with those regs. It's a really important process, and there are materials that you sadly can't use. There is a few examples of them that do work, but they're very hit and miss. So the one we really struggle with the most is walnut. Stabilising walnut is a nightmare. The oilier the wood, the harder it is to stabilise, on the basis that when it sucks in the resin goes in, any oil left in the wood creates like a hydraulic pressure because it compresses the oil. As soon as you start then taking it out, it's under so much tension that I've seen them split and shatter and crack like glass almost. It just shatters the whole thing because it's under so much pressure. So yeah, it's a shame because obviously the gun industry, they love their walnut, but there are lots of woods that look very similar that when stabilised you would really struggle to tell the difference, which is what tends to happen. We get something that is a really close match rather than actually using walnut. But it can be done, but it's really down to the customer. If the customer says, look, I want you to use this particular material, then we will. But obviously we don't offer then warranties on it or stuff like that, or we would advise a maximum lifespan and stuff like that. So it really boils down to keeping that knife clean and keeping that knife sealed from any anything trying to get into it, and it also increases the longevity of the product, which, you know, if we can provide that to our customers, we say, you know, buy this knife, you'll never need another one because it shouldn't fail in any way, and if it does, that's why we have a lifetime warranty. That's the strapline, a knife for life, and we genuinely mean that. So the other question he asked was regarding steel. There are lots of different steels, and he was saying, like, you know, you guys offer 70 different types. You know, how does someone pick? And what really that is the sort of bespoke service. That's where the bladesmith would come in and say, look, this is your application, you're doing X, Y, and Z, you need this steel to stand up to your applied processes, and, you know, and sort of perform in that area. So that's where we can then say, right, we need these steels to do this, and we'll find the best steel for the job. If it was, say, a Hunter, for example, and they didn't specify a steel, it's pretty common for us. We would just default to AEBL, it's AEB-L, or RWL34, which is, they're both powder metals. It just depends on the thickness of the blades and, you know, the size of the knife and little things like that. But in the main, that's what we would go to, because it's tried and tested and true, and we know it performs in most arenas really, really well. But there are a number of processes or a number of elements that we have to look at when picking a steel. This is in no particular order. The first of which is the manufacturability of that steel. And that's not to say how it's being made. That is if depending on the project, if that steel needs to be machined or ground, or, you know, or how that steel needs to be heat treated. Are we even capable of doing it? Have we got experience in doing it? Does our kit allow us to do that? You know, so some steels are really, really tough. Some steels are, you know, hard, like they're very, very hard, and they wear a lot on the machines or wear a lot of the tool heads or stuff like that. And do you have the ability to actually work on that steel? Because if the answer is no, then, you know, you can't use it, so you can't build the project. The second one is hardness, and hardness is basically the measure of that steel's ability to resist permanent deformation. That is the textbook sort of answer, because what some of these things mean to me might mean different things to other people that aren't a bladesmith. So hardness, the permanent ability to resist deformation, which is measured on a Rockwell scale, which we're going to do a separate video on. Now, obviously, there's a sweet spot for hardening steels, and that is done through the heat treatment process, which is the hardenability side of things. Like I said, in that manufacturability, can you harden it? Do you have the kit to harden it? The second one, the third one is the strength, and that is the steel's ability to resist applied force and how that behaves. The next one is ductility. Now, there's quite a lot to go into ductility, about grain size and all that sort of stuff. But basically, it's that steel's ability to flex or bend without snapping or fracturing in any way, stress fractures and stuff like that, or micro fractures. The next one that is coupled with that is toughness. Now, toughness is the ability of that steel to absorb energy, basically, prior to it being broken. How much punishment can it take before it does fail? And it's worth knowing, but is normally done through destructive testing. This one, arguably most important for me, is edge retention, and that is the ability of that steel's edge to hold that edge without need frequent sharpening. And, like, you know, if you go to use it and it's blunted straight away, then there's something wrong somewhere. Now, that can be down to hardness, not necessarily the steel, it just can't have been heat treated properly, or can be down to, like, toughness. If it's damaged in some way, it will fracture and shatter. So there's lots of things that can go wrong, that, you know, that edge retention isn't necessarily the problem. There are other issues in that sort of list that can cause edge retention to fail, but a lot of them need, you know, skilled bladesmith or a microscope to see what you're looking for. Along with edge retention is wear resistance, and that is the ability for it to resist wear and abrasion during use. So if you're, like, you know, chopping logs with it and then suddenly it's got massive gouges up the blade, then, you know, it's not very good at resisting the wear of normal day-to-day use. And then lastly is corrosion resistance. Now, again, not in any particular order these, so corrosion resistance can be quite important. If you're making a diving knife, for example, corrosion resistance is probably one of the first things you'd look at. But like I say, this is just a list of all the sort of elements we would go into. There are also a few others, alloying elements and like contents of the steel, depending on sort of what you're doing with it. But we'll do like a really in-depth, like deep dive onto steel and their grain structures, and we'll show you some grain structures under the microscopes. We'll show you all the hardness testing as well. But this is just like basic what we have to look at as a bladesmith. It's not just, oh, I'll pick up a piece of metal and turn it into a knife. It doesn't really work that way. As you would expect, you would expect, you know, us to be looking for the best thing to make the best possible product, so you guys can, you know, use that product and it then lasts. We don't want to see it come back in a year because it's failed for whatever reason. We want to protect your investment and our work by choosing the correct steel for the correct job. And then the last question he asked me was that why do I always wear black gloves in my videos? And there's two answers to that. First one is I don't want to get greasy fingerprints all over the knives. And secondly, I have been a knife maker for 10 years. My hands are ruined. I've got multiple cuts and I've often got open cuts all over my hands, or bruises or abrasions and all that stuff. And I don't really want to show that off on camera because they look horrible, and I want people to look at the knives that I'm showing off rather than my horribly mangled fingers. And that's it for now. So if you've got any questions of your own, feel free to either leave comment below or get in touch, email, Facebook Messenger, whatever you like. We're also currently preparing for the British Shooting Show, which is in about 4 weeks from now. It's the weekend of the 14th of February. We're going to be there for the full 3 days with about 100 plus knives from all different types, all different ranges, all different materials. So yeah, if you're coming to that show, come and say hello. We'd love to meet you. Like, share, subscribe, help us grow the channel, and we look forward to doing more content for you soon. Cheers.